Hey, this is Wayne from Bit Repairs. Thanks for joining me again for another repair video. Hopefully we'll all learn something today. So I'm just going to switch over to main view now. Got a board here that was sent in for no power. If I just show you the board, this is it. It's an iPhone 6. Standard iPhone 6. So what I've done is I have taken it out of the chassis. If we just quickly we stick it in the chassis again now, I'll just show you. I just stick that back in there. Come on, don't make me look like a fool. There we go. Is that done? Right. That's back in the chassis again now. All I'm going to do is I'm just going to show you what happens if I stick some power into this. So that's that all reconnected. I'm not going to put a screen on it. I'm only doing this for testing. So if I plug that in, that's the battery in. Right, if I plug in here, so I'm just going to plug in now. We're not going to get anything. Not going to get any current draw or anything. Let me just show you on the ammeter. I'll just pull this over here. Oopsie, there goes the camera. There we are. So if I plug that into there, show you on here that we are drawing 0 amps at 5.19 volts. So we're drawing 0 amps here now. Absolutely nothing, dead as a doornail. Now you'd sit in here thinking, yeah, I know this one, this is TriStar. Then it could potentially be. If you've not investigated this anyway, you'd think, yeah, could be TriStar. So what you'd do first is you'd change the battery. So this is what I'd do. I'd take my battery out, do that, stick a new battery in. I'm not going to do it now, but you put a new battery in, you'd plug it back in again, and you'd see if you can get boot there. So if you get boot there, then yeah, TriStar. Because you're getting boot and it'll kill the battery, and then you'll not get it to come back on again. So that's likely that. But this one, I immediately, before I think about TriStar, I immediately go on to look for a VCC main short. So your best place to look for a VCC main short whilst the board is actually in, whilst the shield's on. Let me just switch over to Microscope view. So if you look straight away here, just pull that around a bit. So if you look here at this this connector, this is the home button connector. So if you look down to the bottom left of it, you'll see a small IC, which is this little IC here. This is the camera LDO. Now to the left of it here, this is a capacitor, and VCC main is at the top end of this capacitor. So this is the best place to find VCC main without having to take the board out. So if we put one probe on ground and we put the other probe on there, so we'll check that side, we get a short. We get a 0 ohm short to ground. So we check the other end, and lo and behold, we get a 0 ohm short to ground. So we know that this phone's got a short to ground on VCC main, which is the main power rail going around the phone. So we know that this here isn't TriStar. It's nothing to do with power. It's nothing to do with any of the ICs. There is a short. It's a capacitor. It's possibly an IC, but it's generally a capacitor that's short into ground. So we have a look around, and the first thing I do is look for water damage. Now on this board, you look around the case. Water leaves signs inside a case. You'll notice here, water damage indicator, white. No water damage here, wrong. If we look on the case, don't know whether you can see that here, you can see, there we go, You can probably just about see it there now, but you can see up here in this corner, you can see the typical signs of water damage all around here. You think, right, it leaves like a residue behind. So that residue, I looked on the opposite side of the board, and if we look now at microscope view on this board, you'll notice the most common place. I mean, this is just, it's almost as if the water just goes and straight there every time. I mean, don't get me wrong, it doesn't happen. I say every time, the majority of times. You will get over here, front side of the board looks fine, no damage at all to the front side, not a single drop of water anywhere, not a single sign that this phone's had water damage, nothing around here. So we turn the board over and we're looking and we're looking, and then we look, this is the Wi-Fi IC, and we notice this typical pattern here. This is where the water has come onto there and it's scorched. We keep going down and look at this. This here is C5202RF, and if that doesn't stand out a mile away, you should not be fixing phones. That is absolutely, I mean, you know, that there is just the the sign, you know, the biggest sign you're ever going to get. So what I'm going to do now is just, this cap needs removing, so we're just going to clean the area up first. Let's get rid of all this scum away from here. Let's get rid of all this rubbish. So let's clean the area up and see what we're going to deal with. So let's get another cotton bud. That one's seen better days now. Look, it's that bad that, look at that, it's even taken the copper off the end of the capacitor. So, you know, maybe this capacitor is the one that's causing the problem? I wonder. No, it looks fine to me. We'll leave it there. No, seriously. Right, so what we're going to do is, this one here is actually quite well put in, so we need a bit of hot air. We're not soldering hot air, we're talking now basic hot air, so low hot air. So 100 degrees. I'm just going to go scorpion eye now and have a little look through the microscope. Okay. Trying not to scratch the board with this stupidly sharp scalpel. There we go. So, are we there now? There we go, we got most of that away. I can't see a great deal here through one eye. Can't see depth at all, like I've been telling you every time. So I'm just going to turn that camera off and I'll switch you back to main view. I'm just going to switch that camera off and I'm just going to look properly now, which you should be doing every time. You know, if you're doing this repair, you should be looking with two eyes. Don't be trying to get it right for the camera, you know. I don't do these videos on test boards. I do these videos on customer phones. So I don't particularly fancy ruining a customer phone just so I can get a nice video up and running. Okay, so I've done that. That's all done now. That's all cleaned out. The area is clear. That's it. Switch that back on again now and you can see. Microscope view. Show you that's all nice and cleaned up now. If I can get the camera back on, let's zoom back out again. Where's the board? There we are. So, you know, nicely done here. Right, so what we're going to do, I'm just going to show you now. I'll show you on here. 1 foot on ground, the other foot on there. Short to ground, short to ground. Okay, so we've got a short to ground on both sides of that. So on there, I just get my scalpel now. Let's get the dodgy scalpel. I don't really want to use a good blade for this. I could probably use my tweezers actually. So I'm just going to see if this is loose. So it's not loose, it's quite tight on the board, that. So we're just going to get some flux on there. Now we don't want to heat this area too much because this Wi-Fi IC doesn't get very happy when we put heat near it. So we're just going to protect that a bit first. Put a Kapton tape over it. We want to limit how much heat that IC is going to be receiving. You know, obviously it's going to receive a bit of heat because that component's right there. So we're going to go up to about 300 degrees now. Okay, oh, I missed it. 302 degrees, that'll do. Okay. Okay, I'm just waiting for it to come loose. There we go, we've got that off the board now. So I gave that a little bit of a helping hand, so that's just gone missing somewhere, just dropped it. Right, we don't really need it anyway. All we're going to do now, we're just going to make sure nothing around here is shorting out now, so we don't want any remnants of bits of solder. So we've taken that off. Right, we're going to put one on ground, one probe here, short to ground. The other side, we now don't have a short, we have, if we look on the multimeter main view, you can probably see the multimeter up here in the corner. Can you see that? I think my lights are a bit bright. I did invert this actually. Utility, system, display, invert. There we go, that's a bit better. You can see that now. So if I go there now, if I show you, right, oh, there we go. So we've got open circuit at the moment. So let's just test. Okay. That's ground, 0.1 ohms. This side, we're now getting perfect. Look at that reading now. At the top left corner is what you're looking for. So that's a good reading for VCC main. So what we're going to do now is we are going to zoom in again with this microscope. Right, so we've got a bit of a mess down there at the moment. What I'm going to do first is I'm going to have a little look. There was a little component next to that which was also damaged. So that's not too bad. So that's a capacitor. That one next to it. That looks fine. That does. It's not. It doesn't look perfect, but it's not causing any issues, and it's not shorting to ground. It's just got a little tiny bit of damage from the fallout. Okay, so what I'm going to do now, I'm going to turn my soldering iron on. I'm going to go back here again. We're just going to fluff them pads up now. Okay. Fluff them pads up. A lot of people just leave this, go, sod it, and they just leave it off. I don't like doing that, as you know from previous videos. If a job's worth doing, it's worth doing right. And so we're just going to go over these pads. Stick a bit of leaded on them. Just stuck a bit of leaded solder on those two pads there. Gonna get our hot air again now. Okay, got two nice little pads there. Maybe a little bit too much solder on them. Yeah, a little bit too much for my liking. I'm just going to remove a little bit. I'm going to turn this camera off so I can see. Yeah, there's like way too much on there. I'll see what happens when you try to wing it. What'll happen, you see, if I leave all of that solder on them two pads, is it'll squelch out when the component goes on. Okay, and then when it squelches out, it'll short circuit, and we really don't want that to happen. So I'll just tidy that up again now. Just get a bit of hot air on it. Much better. Nice size pads they are now. So C5202RF is a 10 microfarad, 6.3 volt 0402 component. So let me just see. I can't remember if I ever managed to buy some of these. 2.2 microfarad. No, I did get the bigger ones. Right, I'm just going to look for a donor board now then. So let's just grab this to one side. Okay, let's have a look in our donor board collection for this component, which is probably missing off most of them. There we go. We've got one. Okay. I'm just going to grab that off there with my tweezers. Okay. Right, stick the donor board back in there. Right, we have our donor kebab, our donor component. Let's just stick that in the right place for now. Yep, that's okay. There we go. We just temporarily put it in there for now. It's not actually soldered into place. Looked good though. Looked like I'd just managed to solder that on without even trying. Okay, same again. Let's just... Come on. Okay. Not happy with that. It's a bit too close to that other little component at the side. Let me just have a look at it with the microscope and see what's happening. Yeah, it's just blubbing up a bit at the side. It's I'll show you again. See there, it's just blubbing out a bit at the side. I'm just going to get my soldering iron and give it a bit of a persuasion. Hot air's the answer a lot of the time, but sometimes you just need a soldering iron. Hey, have a little look at that now. Where are we? Okay. Focus. There we go. So that was just a bit of solder, soldering iron, just dab, 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 and we're done. So let's just make sure that that is connected. So short to ground, beep, 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 beep. Yep. This side, 1600 ohms. Right. Turn off, turn off. Wait for that to cool down. Try not to pull the sticker off. There we go. Okay. Let's get some isopropyl on there. Let's clean it all up a bit. Okay. Make sure that's fine. A little bit more. Okay. Yeah, I'm happy with that. It's not perfect, but it never is going to be. Okay, so there's the board. So we're just going to get the case. Let's go back to no, we don't want microscope view. We want to stay on main view now. So we'll go like that. Put the board in there. So our VCC main now is back up to where it should be. As I say, most often than not, this is the cause of the failure on an iPhone 6 when you've got water damage. I mean, there are other places, don't get me wrong, this isn't the only place. This is just a very, very common place where this problem occurs. You probably see there's other videos on YouTube about this exact same problem. I'm probably going over similar ground over and over again that other people have covered. But you know, everyone's got to put their own little twist on things. Maybe you've spotted something's clicked in my video that didn't click in someone else's video. So everyone's got their own ways of doing it and their own ways of learning. So hopefully, if I can get this antenna connector to go into there. Do you know what, about everything that goes in, this antenna connector is the bane of my life. Why does it not go in without a struggle? Everything else, I mean, I think finding a fault on VCC main is easier than getting that antenna to plug in. Okay, so we will plug a screen in this time because we want to test it now. So plugging in a screen. You know, we've no longer got our short on VCC main, so in theory this should power on nicely now. That's it. Now it's a customer phone, so I really don't know if there's going to be any customer data on this screen. So let's go 3, 2, 1. There we go. Look at that. So you'll notice now if I plug in at the bottom, okay, whereas before we were getting 0, we are now getting 0.7, 1.27, 1.14, 1.29, 1.136. Normal boot. So there we go. That is how to fix a VCC main short on an iPhone 6. I hope you've all enjoyed watching, and I hope you've all learnt something today, most of all. And there's going to be plenty more to come where this one's come from. Not sure what to do next, but if anyone's got any good ideas, then please do let me know. I'm really interested in any ideas really for phone repairs. So yeah, it's just great to be able to do something that I really enjoy, and hopefully I'm sharing that skill with a few other people. If you're not able to do this yourselves, please do get in touch. You know, you can post them in to me and I will do these repairs for you. Obviously there's a small cost to that, but yeah, it's been really good having you watch. And thanks very much. See you again soon. Signing out now, Wayne from Bit Repairs, www.bitrepairs.com.